When it comes to material removal operations, a cutting tool should be in contact to workpiece with reference to discrete points that describe both the toolpath trajectory and the cutting geometry. To enable the CNC unit to process toolpath points, a coordinate system should be determined. Therefore, the coordinate system is important for defining the cutting tool's shifts throughout the entire CNC program. To ensure that the CNC unit will succeed on interpreting the coordinates and define the accurate workpiece location in its working envelope, the CNC machine has its own coordinate system. The CNC code for programming machine tools is a kind of a programming language like others available. As such, its syntax follows the same principles and structure as those implemented to computer languages, while it can support logical functions, macros, subroutines, and loops. In its simplest structure, G code consists of a sequence of programming strings or blocks, and these blocks include the several commands. Each command is an alphanumeric word starting with an uppercase letter of the Latin alphabet, followed by an integer or a real number depending the command type. The commands comprising the G code are distinguished to 5 discrete categories. The first category deals with preparatory G commands having the uppercase G character followed by 1, 2, or 3 numeric digits. Even though a significant number of operations is available for performing chamfering and sharp edge breaking, we will present a simple method to accomplish it while the part is finished machined and still clamped to the fixture device of our milling machine. The method is based on simple mathematical formulas while it takes advantage of the special geometrical features of cutting tools dedicated to such operations, such as countersink tool and chamfer tool. In most cases, chamfers appear to engineering drawings corresponding to several parts mention that all sharp corners should be chamfered by 45 degrees. Based on this requirement and the triangular geometry of typical chamfers and countersink tools available, our method applies the suitable CNC program to edge break sharp corners in a vertical 3-axis CNC machining center. G81 Simple Drilling Cant Cycle. This cycle produces holes by feeding to depth at a programmed feed rate and then retracting at rapid rate. It is accompanied by G98 or G99, the corresponding coordinates, feed rate, and R plane. R is the initial feed plane and Z is the final depth of the tool tip. All drill cycles are accompanied by G98 or G99 functions that determine the Z height the tool retracts between holes. Note that X and Y axis positioning in a cant cycle is performed with rapid motion. The following figure depicts the parameters of G81 simple drilling cant cycle. Normally, G81 cant cycle would be selected for centering rather than drilling. X and Y coordinates give the position to where simple drilling is to be executed. Z is used for determining the final depth the drill bit will reach. R is used for determining the reference height to where drilling should start. And finally, F is the feed rate. Special care should be given to reference plane after drilling operation, especially when the cycle is to execute subsequent holes found in the part. If G98 function is used, then the tool will move upwards to a predefined Z height. This facilitates the operation from the perspective of avoiding tool collisions with fixtures, but adds to machining time. In such cases, tool retract can be programmed in different reference planes using G99 command. We begin by moving any tool boxes out of the way to access the machine's coolant sump. We can use a flashlight to inspect the coolant level. The level should be approximately 1 inch below the rectangular axis hole cutout. This level looks okay for now. Now let's check the oil system. The oil is used to lubricate the spindle bearings. Although it doesn't need frequent refilling, it should be checked on a regular basis. Here the oil is just below the max indication.